Something like that. Anyway, someday. To be. Eventually. To be announced. Yes. Anyway, alright. Yeah, I've got a model for the whole thing here, so I'll show you some pictures. And, putting together thing. Really just outstanding work, once again. Yeah, it just is. Yeah, you know, I've gone over it in my head, but I'm going to try to make a list of all the things physics could have gotten right and they got wrong. You know, I mean, I can't even. Round versus square geometry. I mean, they might have figured out that maybe the big universe is just cutting all the edges off because it's big. You know, that really has a lot of little corners to it, you know, the small universe. So, got that one wrong. Particle, wave, photons. Got it wrong. Particles, no waving, nothing like that. They don't wave at all. Either show up or they don't show up, but they don't wave. Yeah, none of that. Push, pull for gravity. They picked the wrong one again. The pull. And that one's like you should have been able to intuitively know the pull just doesn't work. You wouldn't pull. You know, somebody gets stuck in the mic, you don't pull their car, you push it. You know, that kind of thing. The push just makes so much more sense than this pull thing, because the pull thing requires an attachment. You have to find something to grab onto, and then it's all about your grip strength, right? It wouldn't be about pulling. You know, it'd be just about holding. Where push, you just don't have to, you know, I don't have to know you at all, you know, to kick you in the nuts. No connection whatsoever. Moving versus still. Yeah, so the whole ether idea, they, you know, could have got it right. You know, there was a creating one now, right? I mean, the fabric of space. They're creating an ether, essentially, and they just can't figure out, well, wouldn't it make sense, because we need that convergence thing, and that convergence thing going down the well thing, that doesn't work anyway, so why don't we just make the space push, and it'll push everything together, just like it was pulled together. No. Got it wrong again. Time. Time's broken. No, your clock is broken. See, two choices again. Are the clocks broken? Or is time broken? Clock is broken. Duh. Yeah, what's more likely to be stepped on somewhere? A clock or time itself? Yeah, yeah. Duh. Bend or diffract. Yeah, it's another one. You know, things just bend. No. Or are they knocked somewhere? Yeah. Well, anyway, that's just the short list. So yeah, it's just like every time they had a 50-50 chance of getting it right, they bet on the wrong horse. I mean, they're just the worst history of betting ever. The Christians did better, frankly. You just can't get the story this wrong. I suppose they had 7 days to create the earth, and so that's 7 misses, and then you could go, oh, what, the 12 apostles or something, when, well, there's 12 misses, so yeah, they did get a lot wrong, but I'm just saying, they did the do unto others thing, so they got that right. Yeah, this is just so bad. I mean, the more you're just thinking, oh, people. I should have figured, if they have moral or ethical philosophy so fucked up, why would they fuck up physics? Humans are really just they're just dumb animals. I mean, they have all the facts and they, you know, just a ton of facts, and they just can't push two of them together without fucking it up. So anyway, speaking of fuck ups, Ken, Fire in the Sky, left about 17 comments on every video I made, and all these stupid links to Wikipedia pages, no arguments involved. Some of the pages are only a paragraph long about some guy, Dr. Wacko in Wackatonia, you know, stuck his finger up his ass, and when he pulled it out, it smelled like poo, and it's just a brilliant observation of his. Don't do that on my videos, please. Do not leave unargued links on the video. Either argue that it's somehow relevant, or fuck yourself and die and such. And then this other asshole showed up. talking about whatever, tractor beams and shit. Don't do this, you fucking Nazi. It's just, I mean, just disgusting. So anyway, on the bright side, oh wait, it's not the bright side. So anyway, the modern mystic who I like and respect has disappointed me once again. He's posted a link on his economics blog to this new documentary, 2015, Mystery Behind Quantum Theory. It's almost 2:16 now. But it's that stupid cunt, Al Jerky guy, who can't get the two-slit experiment right. He's that arrogant douchebag. And I'm like, this is a video he posts a link in his blog to? This crappy explanation of physics, mystery behind quantum theory. Woo! And there's a guy who's basically saying, look, let's demystify economics. Let's not pretend that the banks use your savings to loan money. No, they use your savings to invest in the stock market. That's what they fucking goddamn do. Like everybody else. Buy the dream. The pyramids, the ultimate pyramid scheme. The stock market. It'll all be good until it goes really, really bad. But let's not learn that lesson. No. Because you're all fucking idiots. So anyway. Just pointing that out for posterity, okay? So nobody could ever say, like with Einstein or something, Gary never thought humans were idiots. Humans are idiot. They're the definition of a fucking waste. They have this big giant brain they keep bragging about, and they can't fucking use it right. So let me be clear. Humans suck more than goddamn fucking ticks. You give a tick a big giant brain, it would probably be able to be smarter than a human. Anyway. Humans are poo eaters. Disgusting. Alright, now I'll get on to the physics. Yeah, I marvel at it, and I just say, oh, it's so simple, you fucking tards. All these big brains, and mystery. No. You know, I'm just, you know, the more you scratch at it, just, like I said, I do it, my nails are longer than they should be. But I mean, I didn't work that hard. I mean, I just scratched at the veneer of their arrogant, pompous, we know everything bullshit. And it just took a little tiny bit of scratching to see, oh, there's a better truth behind this nonsense they're talking. Okay. I guess I'm done with the poetic part of the video. Alright, so, model. The basic function is described is that there's this kinetic energy in the universe. So let's just take all the matter out and just have the universe. And just understand that it's made of energy. There's a bunch of these little bits of energy, and it fills the whole thing because they hate each other. Energy hates energy. It's all, see, that's the thing, it's all push, it's all repulsion first. They won't stick to each other. They fucking attack each other in the sense they fly into each other, exchange directional information. They force each other to go where the other one was going. And that's it. Now, there's a couple of subtle rules to the game. And once those are defined, yeah, you just punch it into a computer model and you'll watch the universe form. That's the neat thing. There's so few rules. So the rule is that the little bits go the speed of light. The rule is they don't break, they don't lose energy, they don't do anything. No crumbling, no nothing. They completely exchange just directional information. The way I was, when I bang into you, I go your way, you go my way. And that's it. And there's 3 fucking dimensions. You know, forward, back, left, right, up, down. Time is not a dimension, space is not a dimension, nothing else is involved at all in this equation except the fact that Yes, it does take time to go distance. No requirement to make a dimension of distance. Okay, there's no such thing as the distance dimension, because the distance can be in one of those 3 dimensions. Distance is a function in a dimension. Time is a function in a dimension. They are not, in of themselves, dimensions. Dimensions have functions. Get it? And the 3 dimensions all function by the same rules. There's no special dimension. No, left, right isn't better than up, down, or forward, back. So 3 identical dimensions, no other dimensions. The rest of the things are just functions in the dimension, time, distance. Space is sort of irrelevant. It's nothing. Yeah, distance is something. The stuff you traverse to get the distance is nothing. Okay, no space, time. Anyway. Okay, got that, right? Alright, so that's what you have. You have this giant field. And as I've pointed out, any place in the field is going to look like there's a bunch of stuff heading right for it. Everything's going to be saying, it's heading right for me. It's heading right for me. The stuff is heading right for it. And that pressure of everything seeming to be pointed right at you, not everything, but your percentage of the universe is heading right for you, your percentage of the energy. The energy that's just going to traverse through the spot you're occupying. Every spot will be collided with an even number of craps from all the other spots, from all the other directions in the dimension. Yeah. So, twinkle, twinkle, little stars. Like one of those twinkly little stars. A bunch of little lines coming in all directions. It's like a porcupine. The little quills all head for your nutsack. But anyway, so yes, you're the center of attention, whether you like it or not, in a sense. No matter where you go, they're still looking at you, kind of a thing. And that's the pressure that ends up pushing everything together, obviously. Because now if I put 2 things close to each other, they will shadow each other from the attention, right? The paparazzi won't be able to take your picture because there's going to be a moon in the way or some frickin' object. And if that object's in the way, the paparazzi is going to push them into you. You get it? Because there's an absence of force. There's you, right? Paparazzi. No. There's you, there's another thing, and then there's the paparazzi. And the paparazzi is going to say, hey, there's nothing in the way. I'm going to push this fucker out of the way. You know, it's going to try to push you out of the way to take my picture because I'm the physics god. Right? You can understand that, right? Say if we're standing someplace in the future, I'm going to be incredibly famous as blah, 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 and you're going to be totally irrelevant. And the paparazzi are going to push you right into me. I better make plans. Better buy like some sort of inverse chastity belt or something. Yeah, no, things being pushed into me. Ew, that sounds pretty creepy. The sacrifices I make for mankind. Shit. Better fucking this better pay decent. But anyway, all right, continuing. So you can get that, right? All right, so now let's go to the drum roll. This is what happens like pretty quickly in this field of energy. Boom. Ooh, looky. Yeah, it's a bunch of arrows. So this is obviously a 2-dimensional rendering. But frankly, that's probably how it starts. 2 dimensions, like a galaxy or a solar system. Just a flat dimension spinning. Spinning. That's it. That's how it starts. So this is how it starts. This flat plane of, as you can see, you probably should be able to see. Now see, this one is in perfect balance. There's just as many arrows going this way as there are going that way, as there are going that way, as there are going that way. So it's all balanced. And no matter how many levels of it, they will continue to be balanced. Surprisingly. Interestingly. But anyway. But this is it. This is the mechanism. So the stuff you can kind of see. I'm back to this little simple square. So all I need is that X idea. You know, the X that could be either go straight through or they bounce off. And once I can get them to bounce off, I can end up creating a box really easy. And this is the box right here. And the box can be expanded and expanded and expanded. And that is a kind of rotation. Now these are just positions in space. So the rotation is an illusion of sorts. It's not an illusion, it's a byproduct, it's a manifestation of the function. But it's not really what's happening. Well, it's really happening, but don't get me wrong. But it's not like you think a mechanical spinning wheel. It's a little bit more of it's a little more complicated, but not much. It's very simple. Like I said, it's just positions that change identity. And what basically is happening here, okay, so let's say now, once you understand that this is what's happening, it's just the pressure forces things into shape, you know, in the sense that if they're going the right direction, this shape becomes durable. It conforms to the rule. Everything's still going the speed of light, in the sense that each location jumps one location per Planck interval of time. So there's no friction rules. Like there's no rule that the outside's going faster because it's one thing. You know what I mean? So if you made these all one thing, little orbiting bullshit, well, they could, you know, there'd be no way to connect the speeds, because this one would have to go much faster than the one in the inner orbit would have to go much faster than the one in the outer orbit, or there'd be drag, and you know, it just wouldn't make sense. You can't make them go the same speed and do the same thing. You can't make something go a big track and a small track, because one would have to go a different speed to what's the word I'm looking for them to be connected. Alright, well, I don't want to get into that too much. So anyway, so let's just say this is the atom in basic sense. In a basic sense, this is the nucleus of it, the fundamental element. Let's call them quarks. But it's going to be deeper than that, because the rest of the things look a little bit like the quarks too. But understand the spinning part. And then sort of understand that I can take wheels, like say if I have a little spinning wheel, I can take another spinning wheel, and if they're spinning the same direction, you know, going down into each other, they're compatible. Now if they're spinning in opposite ways, not compatible. But if they're spinning the same way, they can hang out with each other because they're doing the same thing between each other. And they're not going to like ride on each other because they don't have any physical connection. There's no medium they're swirling in. So unlike what you would think, like, oh look, they're shooting a whole bunch of stuff out and that stuff is going to create a force. No, it won't. It's all kinetic and it's all just a position in space as stated before. There's no momentum involved. So the wheels, when the two of them are spinning together, they're not going to do what you think. Oh, they're going to move automatically. They might move, but it won't be because of the spinning. And it won't be because they're connected. I'm just saying that the two with the same spin are compatible. You know, it's kind of opposite spin, right? Exactly opposite spin is compatible. So now that's sounding kind of like, well, that sounds like electricity and such. You know, plus spin, minus spin, clockwise, counterclockwise, and that this is somehow the nature of arrangement or association. Okay, that same things can't be jammed into each other. Clockwise, they're hitting the back sides, and so they'll abrade each other. The little bits will hit each other in an unpleasant way. So you get the nature of it. But anyway, so just think about that wheel analogy, and then understand that I can keep adding wheels and different. I can have 3 wheels, all rotating. you know, in planes. Kind of like if you were looking top down, it would look like this. And each one's rotating the proper way, and they will all just compatibly do this. So you can start with one flat one, or you can have, you know, so one flat one. And if I put another flat one underneath this flat one, those two wheels would be compatible. So you can sort of understand that if I had two wheels, you know, one wheel here and one wheel here going the same way, those two could sit right next to each other and both spin the same way. So there's different ways you could maybe arrange two, but it doesn't, for the purpose of this conversation, you could just have two going this way also. And maybe that there's only one atom that has two. Yeah, I'm getting to that, right? Two orbitals. They call them something else now, right? It's a plasma. It's a blah, 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 blah. But anyway, but you can understand, so there's only one element that has two, because two, no matter how you do it, would be awkward in that you can't do anything else with it. See, I'm going to explain the vortices now. But that's what sort of these are, just vortices in a way, but you know, without the down part. I'm not, no point in getting all that stuff. I'm just trying to get to the point where you can illustrate in your head that you could have mechanisms that have like a wheel over here, and then there's a wheel over here. So there's two wheels going the same way, and that you can have two wheels going the same way, top and bottom, and it would all be compatible spin. What you can't do is put end ones on, because there's no compatibility on the ends. But if you did do something like that you would tend, or even just three doing, you know, I say I want to confuse, it always ends up, well, I'll show you in the pictures. The point is that this shape, okay, what's basically going to happen as the universe comes in, is the universe comes in and randomly replaces one of these elements. So in this sense, you know, this thing, this space, you could just take this in and put this out in whatever direction it eventually would be in. So you could this is a shortcut. What's really happening is a box will push in here and this box will push out here. So that's what you could think of it as. I don't want to draw it because I don't want to have to draw this again, so I want to Xerox it or whatever. But anyway, so a box would come in here. You can see that's the outside universe coming in, and it would push this arrow out. So you get the idea that stuff comes in from both sides and keeps doing that, keeps pushing the register, keeps pushing things out. But this idea of when it gets pushed out, it does its moving, it goes its space. So in a sense, you can have a field around this thing that's full of these boxes that are getting pushed in and pushed out and pushed in and pushed out. And these next two levels out here could be more broken, like that have arrows going in all kinds of different directions, but that still tend to have this essence out here because it's full of these probabilities. You know, the probability that's 4 to 2, so it's that's 2/3 of the time, no, 2/4 of the time, 1/2 of this, no, it's more than 1/2. Anyway, 2 and 4, it's 1/3. Yeah, I was right in the first place. So 2/3 of the time, you know, these arrows are going to end up being down arrows. And the basic point is what this is going to end up creating is a kind of vortice where it'll go around the side and then come back in here. So what comes out of this side will end up going around and going back in this side, and what goes in, what comes out of this side, will end up going around and going back in. So the thing is there's a little bit of filter. There's a fudgy zone that will continue the spin in that it's still spinning. But what it's doing is it's taking 1/2 to one side and then 1/2 to the other side and replenishing the ins and the outs. So I couldn't find a great way to draw it. But the idea is this stuff comes out of this side, goes over here, ends up being an input here. Stuff coming out of this side ends up going around, comes back into the input here. And that's the nature of the field lines you see in a magnet, or the idea of the conducting of electricity and the little, the lines you see that go through the conductor and the field, and that's what's really happening, is all the energy part of the matter is moving across the surface and through the center. Because I say through the center because of the shape. I'm going to suggest it might be a lot of matter, especially the magnetic matter. But anyway, so that vortice is essentially this outside space. So this would be your neutron kind of idea. Your neutron proton would be this thing. So you could say the interior, this interior is the proton, and this exterior is the neutron, and then you have this space called the electron. But that's what I'm saying. Their model isn't really a good model, because it's really about the state of the locations and the fact that they move around. So the state of these locations are constantly getting kind of banged around by the universe coming in and screwing everything up, and then it has to reorganize in a sense. But it will naturally, because the tending pressure is to, whatever it takes away, whatever it breaks in here, it puts back out here. That's the nature of the field. So whatever you change inside the field, it goes into the external field, and the tendency is it's going to come back again. So it's hard to lose something once you have it. So once you have an arrangement, the arrangement becomes durable, because any breaking, any parts that fly off will have a chance to pop back in. And so that durability is what this whole thing is ending up being about, is how do you create a durable arrangement, an arrangement that can survive the sometimes erratic bombardments of a random, chaotic universe of energy. And I only mean random in that its first creation, all the arrows were in a direction, and then somebody said, go! And they started moving, that kind of thing. And everything was sort of dictated by that first pattern. In terms of its evolution, its progression by these simple rules. So just understand the simple, just keep going back to those simple rules. It's just exchanging directional information. This thing here is going this way. It hits this thing here. They exchange information. This becomes this arrow, and essentially that one becomes the other arrow, the out, the down. So that's all that's really taking place, is you're just exchanging identity with this guy. So if I'm coming in this way, this arrow becomes a this way arrow, which is, very counter the flow, but it still will be fixed because it's not going to be durable. This will be durable. That will be wiped out because that's the majority. The majority will win, in a sense. That's the probabilistic obligation is once there's a majority, you can't kill it. So that's really one of the rules, is once you establish a 3-to-1 advantage, no matter how, obviously in the middle of a nuclear bomb, you're not going to survive. That piece of, the matter will break down because there's too many arrows going one way, and they just wipe out the existence of the material and push it 5 miles away. But I just mean for the common experience in the universe, there'll be an instant durability because the majority will win all the votes, all the elections. So that's just important to realize that all that really is going to happen is that there's a square here, and technically it bangs into it. It does this whole thing I'm saying, this kinetic thing. But for the purpose of understanding, all you have to recognize is the two things essentially just switch. This becomes that, and that becomes this. And because it's still going the same direction, it's still in this game. It's still in the close field. And so there's a good chance it will end up back in a position where it will cause motion in this direction. And if not, the irony will be is there's another atom down here, and that direction will end up feeding this atom's direction. Its spin. That's why the spins have to be complementary. So the two things can be next to each other, and if one's spin gets weak, the other one can be pushing more spin in because it gained the excess bit of spin. The flow around it, the eddy, the whatever you want to call it, the electron, carried the force into the flow, and the flow is now spinning the other wheel more regularly. It's putting back the arrow it lost. So you can almost see that as being very intuitive. That as the two things spin into each other, they'll just keep putting things back into each other. Where necessary anyway. So I'm just saying, if the wheel isn't self-correcting, it will inevitably, by a probabilistic rules, end up fixing, okay, some error, some imbalance in some other wheel, because all the imbalances will be moving the same way. You know, you're all going to be spinning in these opposite directions, so imbalance this way will be balanced to this one, because it's going, you know, it's the right side rule. What comes out of your left side is just what your right side needs, kind of idea. I don't know how to put that better, but it works. I hate to say trust me. Trust, yeah, you have to think about this. I mean, I don't know, this isn't that complicated, but people will somehow get lost and say I'm saying something I didn't say, and I guess that's the tricky part. So just understand that this is rigid. These things end up being a very tight configuration. Not much error in here lasts long. And out here is where it gets fuzzy, and this is like essentially the electron space. And this is the carrier. The electron is essentially the carrier of the energy of the spin. The spin is the electron is the substance of the spin, the meaning of the spin, the atmosphere or something, whatever, however you want to understand it, but it's carrying the message, spin, movement, and I don't know how else to say that. I'll come up with a better way to say it. So anyway, so if you kind of get this, so these are flat planes. And so I can sort of show you like an atom might look. Well, I won't get into that. That's sort of, this isn't exactly what I was getting to, but you could understand the force dynamic in that the spin is going to create rotations in certain, you know, the flow dynamics, and so that's going to create compatibility, but there'll be incompatibility in the other spin. So one face there's compatible spin, the other face there's incompatible spin, and that's what's keeping atoms from being able to connect to each other. So they just end up keep wobbling between attraction and repulsion. And you see that in magnets. You can put a bunch of magnets around another magnet, and the attractive force will do one thing, the repulsive force of the smaller magnets will do another thing, and the whole thing ends up being balanced, and none of the magnets will move. They can't either be attracted or repulsed, and you could just put it essentially in a box, you know, so to speak, and the magnets won't move. They'll just stay, you know, as long as you have a frame forcing them to be pressurized, they'll just stay in that configuration. They'll just stay that way because they can't either attract or repulse anymore. They're denied the opportunity to. So anyway, it's that pressure. You can sort of understand that if the whole universe is pushing in on this arrangement, it's going to force these things to become very tight. You'll force repulsion to its limit. Attraction is essentially repulsion, but I want to, again, that's back to the spin idea. It's neither spin. There's the compatibility just means that you can get close. It doesn't mean that the spins will eat into each other. So again, it's like spinning tops. Even if I have compatible spins with spinning tops, they'll still bounce off of each other. You know, they don't jump into each other, or pop up in the air automatically, or do something like that. They bounce off of each other, but they bounce off more if they're spinning reverse than if they're spinning the same way. That's the difference. The repulsion is stronger if they have opposite spins and weaker if they have common spins. So it's, again, it's all a negative system, but it's big negative versus little negative, and that creates enough of a difference to make the difference. All right. So I'm hoping you have, well, I hope you get this. I mean, I hope you get what I'm talking about. So again, this three thing is where, you know, you can sort of see where the vortice starts being created if you have these three wheels and they're all spinning into a center, and there would be this, and then the centers are all spinning the same way, right? So they're all feeding in here, and they're all pushing out at the bottom, and you could sort of see that instantly we end up creating these vortices, or these complementary harmonic flow in the field around them, because everything that pops out of them, every unit that gets replaced is going to end up flowing in this near field around it, and it's going to take it a while to get really far enough away where it's back in the field, and you actually did lose something that you're not going to get back. So it would take a while for it to get far enough away where I'm gone forever. I just went to Pluto and I'm not coming back. And so then you're stuck with that bad arrow in your mechanics, so to speak. The error bit. And you can only have a certain number of error bits, and then this whole thing falls apart. But you can understand that this could be durable enough. If this is made out of 1,000,000 bits, you can understand that it would be pretty durable. That, you know, I could put 15 bad bits in, you know, bits that disrupt movement, cause Brownian motion, and I'm not going to create enough motion for the whole thing to fly apart. I'm just going to create a little bit of agitation to the spin. The spin's going to go a little wobbly because I put in some wrong direction. You can sort of get that, right? You can sort of get that that's why a wheel wobbles, right? It's because it's got too much stuff going in the wrong direction. It's too much going one way, not enough going back the other way, so it gets all wobbly, out of shape. Well, atoms get out of shape. Electrons get out of shape. Anything, like I said, this is the fundamental matrix, so you could just say that, you know, a quark could be 50,000 of those, and a proton could be 1,000,000,000, that kind of thing. You can have these wafers in different sizes, and size would probably be associated with durability, certainly. But anyway, so the other thing I wanted to do with atoms was to say, okay, so you got this idea of two wheels spinning complementary, just flat next to each other. So you got the idea of one wheel, and here I'll put one wheel here. So you got one wheel, then you got two wheels spinning this way, close to each other. Then you got three wheels doing this. Now this scenario could just be increased, you know, by adding 4, 5, 6. So this might be the way the wheels connect to each other. And it might not do any of this square geometry, but I thought this square geometry was kind of interesting. Because what you can do is have 4 wheels doing the, you know, 2 going this way. Well, they're opposite. Right? This one's going this way. This bottom one's going this way. Well, that's easy. That's it, yeah. So, but they're separated by these wheels going this way on the side and this way on the side. So the 2 wheels opposing each other are opposite spins. And this is an empty going in here. So you can understand that this would create 2, or 4 even, things around each one of these openings. They would have a subtly different flow, and some of the flows would be stronger than others. And so if I wanted to, I could make this a 5-sided with a hole in the middle, or a 6-sided with a hole in the middle. And that might be how atoms have further and further orbits. So they're saying there's like 7 now. I think there's only 6, but they're saying there's 7 of these planes connected. For the bigger the atom, the more planes that can be connected. But you can sort of understand how that system of those flows would get quite complicated as you're adding more sides, because of the geometry it creates in this middle section. And so they would end up, these flows would end up hitting each other, going the wrong way, and you know, opposite spins. And that would be the sense radiation is being caused by the eddy currents, the extra currents, smashing into each other and allowing energy to be lost through the extra interactions that take place through that. It escapes the field. The field gets weaker in terms of its overall flow because there's too many too many opposite spins, so to speak, too close to each other. All right. So yeah, so the idea is just to understand that this is a hole essentially through a plane, okay, of disks, and that might be called an atom, and that these flows would be what would be considered the electron orbits. Now, the very nature of an electron could be wafers like this, you know, smaller ones, that are part of this flow dynamic. And because they have a little bit of form, they're durable, and they'll just keep moving with that flow. They won't be able to escape it because they tend to have a structure. I mean, the bigger it is, the more likely it is to be pushed into this big structure, because there's lots of blocking energy that starts to form around this thing. So you have to keep remembering that the thing really pushing all this stuff together is this external force that keeps obliging it to try to create geometry. There's the external force is always trying to find a way to configure these pieces, these spins, so they take advantage of their complementary space. So they get as close together as they can, and the only way they can get close together is to have complementary spins. So keep understanding that's what the pressure is really trying to. That's the nature of matter, or the creation of atoms or structure, is that there's less space used by the same spinning disks if they spin complementary to each other, and that they have to be further separated because they keep bouncing off of each other like the spinning tops. They'll keep bouncing off of each other if they have opposite spins. So the idea is that the external pressure is going to keep rewarding with durability spins that are closer together. Condensation is the preferable state. The more survivable state is the compressed state. All right. So, but yeah, I haven't drawn any rock solid. The only thing I'm connected to is the idea that this is the nature of all the particles, the things people call particles, protons, neutrons, electrons. They're not a particle, they're a collection of quanta. So understand, a photon is just one of these, just like the gravity coming in, just that external pressure. A photon is just one of those with a frequency. So it just comes at a regular period, a very regular 3 spaces, 3 spaces, 3 spaces, there's 1. So it's just a pattern of arrows, all arrows going, say, this way. They're all in the same vector, the same line, and they're just spaced by a distance, and that's a photon. So this would be a graviton would just be one of these things without any set frequency. It's not connected to any others. And a photon would be one that has a frequency. And depending on its frequency, depending on the distance between the arrows, the impacts, the times it hits this wafer, depending on that distance, the wafer will behave differently. So if it gets, certain frequency of pattern, depending on the size of the wafer, will dictate whether it will be absorbed by the wafer or rejected by the wafer. And you can sort of understand that this flow, it's going this way, sorry, that this flow means that something can come in here and leave here. It will escape the local field here, or it could escape the local field going this way, or it could escape the local field going this way. You get it? Quite profound. So, yeah, I think we'll leave it at that. I don't think I need to. This is as far as I've taken it so far. Only had it in my head for a day, but this looks like this square geometry works on the small level, even if it is not square. Even if quantons are. Just remember that we sort of know that photons are polarized, meaning that they're probably flat and that they can come at you in 2 dimensions. That's polarization. And that's these wafers that make up atoms, more complex structure, these spinning wafers, so to speak, spinning in principle, spinning probabilistically, are also flat. But when they connect to each other to become matter, an atom, they lose that flatness and they end up creating a common field of regeneration or so the point is that you could sort of understand it. That I put 3 of these spinning wheels all the same, and then I gave it a forward motion, that the spin would create this idea of taking what was in the front and putting it in the back, taking what's in the front and putting it in the back. So it's all those forward arrows that you're losing going forward would end up going back, coming to the back end, and then pushing it again. So it just keeps regenerating the velocity, because the arrow you lose, this going forward, because something hit you from behind, so to speak, or hit you, whatever. It's all balanced in the field. So you're running through a balanced field, but you have an imbalance built into your mechanics. So you keep spewing arrows from one end going forward, and those forward ones end up getting brought all the way back to the back again, and you get to do them all over again. So they're just going to keep reclaiming them, and you're not going to get rid of your imbalance. So the imbalance in here, like I said, think of this as a million of these squares. I'm just saying. And just remember that it's like only 5% or 2% or 1% of them are out of this arrangement. That goes out into the field, and then the field has this tendency, this weaker field, this weaker pattern, it just gets weaker and weaker as it goes out. But that's enough of a swirl to take what's at this end and bring it back to this end. And most especially when you create these kinds of mechanisms that allow for these vortices to form. Not vortices, but whatever the lag current around the wheel would be. Kind of like if I spin a wheel in water, you can kind of see the water spin around it, but I don't want to use comparisons to water because that's what the 2-slit lunatics have done and ruined physics. But it works that way just because there's not a direct drag with the medium, but there's a probabilistic drag that exists, and that you can't lose something to the far universe, you can only lose it to the local field. So it's not like when this thing loses something, it's gone, goes way out here. Now it stays local, and it stays local and stays local, and then but the further out it gets, the less likely it is to come back again. But because it's not so too far away, it has a chance to end up back in the flow, back in the probabilistic order. All right, so I think that keeps. I don't want to do this to death because it's really preliminary, but I think this is it. This is rock solid. I think it just fits with the magnetism thing. It creates the idea of polarization. It's just spin dynamics. It just makes it all make sense. It just does. So booyah or whatever. But yeah, I think this is it. So anyway, so I just got to write papers on each one of these. 2-slit paper. I got to do a 2-slit paper. I got to do a gravitational lensing paper. I got to do a push versus pull force paper. I got to do a square geometry versus round geometry paper. But I think that's the way to go, is just to write short papers on narrow subjects and see if I can get one of them published somewhere, and then we'll be off to the races, right? I would hope. So much to do. It's almost one person, It's hard being God, the God of physics. Hell of a responsibility and such. Yeah, just unfair. I have to do everything. I have to do everything on this planet. Anything good that's getting done, somehow it's me that's got to do it. I don't get this. This is not fair. Anyway, till next time. Hi, Mom, and whatnot. Just watch my videos. Fucking family doesn't watch my own. well, we thought Gary was kind of retarded. Well, you know, so we didn't, well, you know. Yeah, well, fuckers. See you later and such. See, these Vortice thing, this whole conversation though should appeal to that stupid photographer cunt guy who has me blocked. Who says, oh, I want to discuss physics. Yeah, and he blocks people. Because why? Oh, because I disagree with you. I mean, that's really lame. I mean, blocking people because they're obnoxious. I mean, I posted one comment. It wasn't even a comment, just a link to a reply video. And I got blocked. I mean, fuck. Yeah, gee. Sorry.